Module 5 Web3.js and App Development. Today we'll cover the fundamental concepts of building React components, which are the building blocks of any React application. We'll learn how to create reusable components, manage state and implement interactivity to build engaging user interfaces for decentralized applications powered by Web3.js. What are React components? We already did this in the last class, but again, a quick recap. React components are the building blocks of a React application. They are reusable independent pieces of a user interface that represent specific functionality or visual elements. Components can be thought of as JavaScript functions or classes. Cut. HTML-like code known as JSX, which describes the UI to be rendered. JSX stands for JavaScript XML. Right? Okay, so components allow developers to break down the UI into modular, self-contained pieces that can be composed together to create complex user interfaces. This makes the code base more maintainable, testable, and scalable, as changes to one component do not affect the rest of the application. So now let's discuss the types of React components. First are functional components, and the second type are class components. Functional components are written as JavaScript functions that run JSX code, right? JavaScript XML code to describe the user interface. They are the most common type of React components and are generally simpler and more lightweight than class components. Whereas class components are written as ESX classes that extend the React.component base class. They provide more features and lifecycle methods than functional components and are often used for more complex UI logic and state management. So you might have the question, what is ES6, right? So ES6 is also known as ECMS Script 2015. This was the sixth edition of the ECMS script language specification standard. It was released back in 2015 and it majorly brought a significant update to JavaScript, adding new syntax and features that made the language more powerful and easier to work with. This enhances the capabilities of JavaScript, making it more efficient, easier to read, more robust for building modern web applications. Okay, so now let's talk about creating a functional component. Functional components are the simplest and most common type of React component. They are written as JavaScript functions that return JSX code to describe the UI. Here's an example of a simple functional component that displays a welcome to React message. Function welcome, return welcome to React exclamation mark. Code default welcome. So the key thing to note in this code is that the functional components are just like regular JavaScript functions. They take in props if necessary and return the JSX code to be rendered on the screen. This makes them very lightweight, easy to understand, and a great choice for many UI elements in a React application. Now let's talk about creating a class component. So class components in React are ESX classes that extend the base React.component class. They provide more features and lifecycle methods than functional components, making them suitable for more complex UI logic and state management. So now let's talk about the render method. The most important method in a class component is the render method, which returns the JSX code to be rendered on the screen. This method is called whenever the component needs to update its visual representation. So finally, you have to export the component, right? To use a class component in other parts of your React application, you need to export it using the export default syntax. This makes the component available for import and to use it everywhere elsewhere in your code base, right? Okay, so here's the code example. Okay, so first you import React and component here, right? So the first line imports the React library and the component class from the React package. So React is essential for creating components and component is the base class for defining stateful components. Next is class declaration, right? It declares a new class called welcome that extends react.component. By extending component, the welcome class inherits methods and properties needed to create a React component. Finally, you have the render method, which is unique here. The render method is required in class components. It returns the JSX that defines what should be rendered to the DOM. In this case, it returns an H1 element with the text welcome to React exclamation mark. Finally, you are exporting the component. This line exports the welcome component as the default export of the module. This allows the component to be imported and used in other parts of the application too. Okay, so now let's do an overview about JSX. So JSX is a syntax extension for JavaScript that looks very similar to HTML. It is used with React to describe what the UI should look like exactly. JSX makes it much easier to write and add HTML like code within your React components, providing a more readable and intuitive way to define the structure of your user interface. For example, you can create a simple JSX element like const element h1 hello world exclamation h1 that will be rendered as an h1 heading on the page. This allows React developers to combine JavaScript logic and HTML like markup in the same file, making the code base more organized and maintainable. So now let's talk about rendering components. In React, the React DOM.render method is used to render a React component to the DOM. This is the entry point for a React application where the top level component is mounted and displayed on the web page. Import React from React, import React DOM from React DOM, import welcome from dot backslash welcome. And finally, React DOM dot render welcome backslash document dot get element by ID root. The React dot render method takes two arguments, the React component to be rendered and the DOM element where the component should be inserted. This allows us to seamlessly integrate React components into an existing web application or to create a new application entirely powered by React. So now let's talk about props in React. In React, props are arguments passed into React components, allowing data to be passed from parent to child components. Like how you inherit genes, right? Kind of like that. That's an analogy you can use. This enables us to create reusable and configurable UI elements that can adapt to different use cases. Function welcome props return h1 hello props.name h1 welcome name equal to Alice. For example, you can pass a name prop to a welcome component like this. Okay, welcome name Alice. Inside the welcome component, then you can then access the name prop and use it to display a personalized greeting. So I'll take an analogy. This might seem a little complicated, but I'm trying my best here. So for example, you have a parent and a child, right? So let's say the trait is eye color. So you can pass the, for example, imagine you're the person who is giving the gene from the parent to the child. I know that's not how biology works, but let's take it like that. So you can decide whether you want the eye color to be green from the mother or blue from the father. You have a choice in that. Think you're the DNA who makes the choice or something, right? So you can pass a prop, right? You can pass the eye color as a prop to the eye color component. So I can either pass green or I can either pass blue. And it will change the eye color in the child accordingly. A personalized eye color will be displayed. Okay. So now let's talk about state in React. So functional component state. In React, state is the internal data of a component that determines its behavior and rendering. The example demonstrates how to use the use state hook in a functional component to manage a simple counter state. The count variable holds the current value and the set count function updates it when the button is clicked. State updates and rendering. When the state changes, React automatically re-renders the component and its children, ensuring the UI reflects the new state. This reactive nature of state management is a core concept in React, making it easy to build dynamic and responsive user interfaces for web applications, including decentralized applications, dApps, powered by technologies like Web3.js. So, state management best practices, right? Let's talk about the best practices. Effective state management is crucial for building scalable and maintainable React applications. Developers should aim to keep state as local as possible, state up when necessary, and use tools like React Context API and state management libraries like Redux, MobX for more complex state handling scenarios. Redux and MobX are state management libraries that are commonly used. Okay, so now let's talk about a code example of using state in a functional component. Okay, so let's talk about the code here, right? Yeah, so first we are just importing React and useState, right? The first line imports the React library and the useState hook from the React package. And the useState hook is a function that lets you add React state to functional components. Next, we're just declaring the state initialization with useState. The useState hook is called with an initial state value of 0. The useState returns an array with two elements, the current state value count and a function to update the state, set count. Next, you are rendering the component. The counter component returns a div element containing a p element that displays the current value of count. A button element, when clicked, increments the value of count by calling set count count plus 1. Next, you're just exporting the component. This line exports the counter component as the default export of the module. Okay, so let's go to the next thing, which is handling events. Handling events in React. In React, event handling follows a declarative approach similar to how you would handle events in plain HTML. However, React provides a more intuitive and consistent way to bind event handlers to components. Next, we are talking about handling button clicks. For example, to handle a button click event, you can define a function like handle click and pass it as the on click prop to the button element. When the button is clicked, the hand click function will be executed, triggering the desired action. Now let's talk about the best practices that you should follow for event handling, right? So such practices are like keeping event handlers as small and focused as possible, optimizing optimizing performance by memorizing event handlers and using the appropriate event handling mechanism. Example, synthetic events, DOM events based on specific use case. Okay, so this is just a small code example of handling a button click. Function handle click, alert button click, button on click, click me button. So now let's talk about conditional rendering. Conditional rendering allows you to dynamically render different UI elements based on the state or props of a React component. This powerful feature enables you to create more dynamic and responsive user interfaces that can adapt to various conditions and user interactions. Function greeting props. If props is logged in, return h1 welcome back, return please sign in. So it's condition, right? It's similar to an if statement you have used in other programming languages. So, for example, the greeting component shown in the code snippet checks if the user is logged in and renders either a welcome back exclamation mark message or a please sign in full stop message accordingly. This type of branching logic is essential for building modern web applications, including decentralized applications powered by technologies like Web3.js. Like a simple if else condition you have explored in different programming languages, right? Like in Python, C, C++, Java, you know what if else conditional statements are. So it's similar to that. So now let's talk about lists and keys. In React, rendering of lists of elements is a common task. To do this effectively, you can use the map function to iterate over an array and generate a list of corresponding JSX elements. Each list item should have a unique key prop, which helps React keep track of which items have changed, been added, or been removed. The key is typically set to a unique identifier for each item, such as an ID or index. Const numbers equal to 1, 2, 3, 4, 5. Const list items equal to numbers dot map number. Li key equal to number dot toString number. UL list items dual. So what this example code does is it demonstrates rendering a list of numbers using the map function and assigning a unique key to each list item. This pattern is essential for building dynamic user interfaces in React, including those for decentralized applications powered by Web3.js. Now let's talk about forms in React. In React, forms are often implemented as controlled components, where the form data is managed by the component state. This ensures the form data is controlled and updated solely by React, providing a more robust and predictable user experience. The example demonstrates a simple name form where the input value is bound to the component state using the useState hook. The handle change function updates the state whenever the user types into the input field, and the handle submit function is called when the user submits the form, displaying the entered name. This pattern of using controlled components for forms in React allows for easy validation, error handling, and data synchronization, making it a preferred approach for building complex and feature-rich web applications, including decentralized applications powered by technologies like Web3. So the code example I mentioned before, right? I just gave a brief explanation, but let's discuss this code in detail too. So both from the React library and the useState hook function from the React package, right? The useState hook is used to add state to functional components. Next is just declaration of the functional component name form. Next is state initialization with useState. I have mentioned this before, right? The useState hook is called with an initial state value of an empty string. The useState returns an array with two elements, the current state value name and a function to update the state, set name. Okay, so next what we'll do is handle change function. This function is called whenever the value of the input field changes. It takes an event object as its argument and updates the state with the new value of the input field. Event target dot value. Next you have your handle submit function. So this function is called when the form is submitted. It displays an alert with the current value of name. It calls event dot prevent default to prevent the default form submission behavior, which would reload the page. Next is render method. So this component returns a form element with an on submit handler, handle submit. Inside the form, there's a label containing an input field of type text with its value bound to the state variable name, and an on change handler, handle change. A submit button of type submit with the value submit. Finally, you're just exporting the component. The last line will export name form component as the default export of the module. This allows the component to be imported and used in other parts of the application, as we have discussed, right? Okay, so lifecycle methods. So first is component did mount. This method is called immediately after a component is mounted, inserted into the tree of React components. It's an ideal place to perform any necessary setup such as making API calls or setting up event listeners. Next is component did update. So this method is called immediately after updating occurs. It allows you to perform actions in response to a prop or state change, such as making additional API calls or triggering a DOM update. Next is the component will unmount method. This is called immediately before a component is unmounted and destroyed. It's the best place to perform any necessary cleanup, such as invalidating timers, canceling network requests, or even removing event listeners. So, talk about an example component user card. So, the following example demonstrate how to create a reusable React component for displaying user information. The user card component takes in props such as the user's name, email, and renders them in a clean and visually appealing card layout. So the component uses JSX syntax to define the structure of the UI with the user's name displayed as an H2 heading and their email address shown in a paragraph. This modular and declarative approach to building UI elements is a key principle of React development, making it easier to build complex user interfaces for web applications, including decentralized applications powered by technologies like Web3.js. So here again, as I told, right, function user card, you have props, right? It accepts props, and you're returning div class name user card, h2 props.name, and p email props.email and div. So user card name Alice equal to alice at example.com. I hope you understood the example. You can go through it again if you want. So let's now talk about composing components. Right, so combining components. So as you know, composing components is a fundamental technique in React development. By combining multiple reusable components, right, you can build complex and feature-rich user interfaces for your web applications, including decentralized dApps powered by technologies like Web3.js. Next, we'll talk about nested components. The example shows you how you can use multiple instances of the component within the top level app component. This allows you to display a collection of user profiles in a clean and organized manner, demonstrating the power of composing components to create sophisticated UIs. And finally, let's just discuss the best composition practices. So, effective component composition involves breaking down your UI into smaller reusable pieces, focusing on single responsibilities, and passing data and functionality between components through props. This model enhances code organization, maintainability, and testability, making it a best practice for building scalable React applications, including dApps using Web3.js. So here's a code example of composing, right? Function app return div, right? So you're using two user card names, right? So this is the composition happening. User card name Alice, email equal to alice at example.com. User card name Bob, email equal to bob at example.com. So you're composing two, right? So this is what you're doing. In the function app, right? You're composing both of them. In the app function, you're composing both components. user card name Alice, and user card name Bob. So this is composing of components. Let's talk about styling components. In React, you can apply styles to your components in various ways, including inline styles, CSS style sheets, and CSS in JavaScript solutions like style components or emotion. Inline styles, as shown in the example, offer a simple and flexible styling individual components. So the example will demonstrate how to define an object with CSS properties and then apply it directly to a React component using the style attribute. This makes it easy to dynamically apply styles based on component state or props, enhancing the overall responsiveness and customization of your user interface. So this is the code example of inline styling, right? It's very basic. Const div style, color you have put it as blue, background color as light gray, padding as 10 pixels. And then function style component, return div style, style component. This is very simple, right? Basics essentially. And now we'll come to CSS modules, which is a bit more trickier than inline styling, but it's pretty easy once you understand it. So let's talk about the CSS modules basics. CSS modules allow you to scope your CSS styles to an individual components, preventing naming conflicts and improving modularity. By importing a CSS file as a module, you can access its styles through a dynamically generated class name, ensuring your styles are isolated from the rest of your application. Next, we'll talk about integrating with React. In React, you can easily integrate CSS modules by importing the CSS file as a module and using the generated styles object to apply styles to your components. This approach helps you keep your CSS and JavaScript code tightly coupled, making it easier to manage and maintain your application styles. So, what are the benefits of CSS modules? CSS, as you know, stands for Cascading Style Sheets. I am sorry I didn't mention it before, but I'll mention it now. CSS stands for Cascading Style Sheets. So, these offer several benefits, including automatic class name generation, improved code organization, better scalability, and enhanced developer experience. By using CSS modules, you can write more modular, maintainable, and testable CSS, which is particularly important for building complex web applications, including apps powered by Web3.js. So now let's talk about examples of using CSS modules. I'll explain this code, right? So first is CSS module app.module.css. So this is a CSS file that will be treated as a module, and CSS modules are scoped locally by default. So styles defined here won't affect other parts of the application unless explicitly imported and used. So be careful about that. Okay, so you have dot header class. A CSS class named header is defined with two styles: background color as light blue and padding as 10 pixels. So it adds 10 pixels of padding around the content. Then is your React component header.js. So we import React first of all. It might not be mentioned here, but you have to import React, right? That's very obvious. So import React from React, right? And then what you do is import styles from /app.modules.css. This imports the CSS module. The imported styles object will contain properties corresponding to the CSS class defined in app.module.css. Each class name becomes a property of the styles object with a unique name to avoid conflict. Header component. Okay, so function declaration, it declares a component called header and return JSX. The component returns a div element with a class name set to styles.header. This applies the styles defined in the header class from the CSS module. The text content of the div is header, right? And then finally, you can also export the component. It's not written here, but you know, right? We have discussed this before. You can write export default header. This will export the header component. This will export the header component, so it can be imported and used in other parts of the application. Fine, let's talk about debugging React components. So React Developer Tools. The React Developer Tools extension for Chrome and Firefox is an invaluable tool for debugging React applications. It allows you to inspect the component tree, view component state and props, and identify performance bottlenecks in your application. Next, we'll talk about console logging. So, leveraging the browser's console for logging is a simple yet effective way to debug React components. You can use console.log, console.error, and other console methods to output valuable information about your component state, props, and lifecycle events. Next, let's talk about troubleshooting techniques. Alongside these specialized tools, employing general troubleshooting techniques like step by step debugging, component isolation, and error handling can help you identify and fix issues in your React components, ensuring a smooth experience for your Web3.js powered apps. Okay, so finally, let's talk about a conclusion and I'll also further reading. As we have learned today, React is a powerful JavaScript library that is used for building UIs, including those for dApps powered by Web3.js. Today, what we covered were the fundamentals of React development, from components and JSX to state management and even lifecycle methods. So, to continue your learning journey, I encourage you to explore the official React documentation, which provides in depth guides, API references, and best practices. Additionally, there are many excellent React tutorial videos on YouTube that can help you deepen your understanding and gain practical experience. Finally, engaging with the vibrant React community through forums and discussion boards can be an invaluable resource as you continue to build your skills. And that's it for today, I guess, and I'll see you guys in the next one. Bye bye.